So let's continue on now, David, to our next demo case.
All right. Thank you, Adam. So you introduced some of the constructs the platform team can use to manage policies. Let's dive a little bit deeper into how that works and how does it create automation. So first thing, let's talk about the problem we're solving. So the downside of microservices is that there are a lot more policy enforcement points. You have sidecars, ingress gateways, load balancers, and what have you. So adopting Istio and Envoy gives you more power and flexibility, but they actually create a bit more problems. Traditionally, you would power through the problems by manually setting policies and propagating them throughout the service mesh, and that doesn't really work anymore. So the first problem is just the sheer volume of configuration provisioning that has to happen. Then to make it worse is the complexity to reflect the dependencies. Security mandates often follow hierarchies of an organization. You have a global policy set by the security team. You have a business unit policy, or you even have policies at a service level. And that really depends on your organization structure and makeup. And lastly, even if you could figure that out, the underlying service is too dynamic. So new services spin up and shift. Manual configuration simply doesn't work. Security gaps emerge if you're doing it manually. So to make this work, basically every organization needs some kind of automated management plane to define, propagate, and enforce policies. So how can platform teams really get that automation without building it on their own? And the answer is automated security policy enforcement in Tetrate Service Bridge. And here's how it works. So you can map the hierarchy of your organization in Tetrate Service Bridge with a tenants and workspaces construct that Adam introduced earlier. And once the hierarchy is there, you can apply a policy at the tenant level or the workspace level, and the policy will be propagated down the hierarchy automatically. And the power is not just in the hierarchy. I like to call out that you as the admin can also set rules on how the policy will be propagated in the hierarchy. So if it must be strictly followed or if exceptions are allowed and for whom. So Adam showed you some of that. And if you have a matrix organization where permissions aren't strictly hierarchical, we're introducing the concept of security domains, which allow you to create custom groupings of workspaces or tenants outside of the workspace tenant hierarchy, so you can have the flexibility to create exceptions quickly. So we're not just stopping at making policy enforcement smarter, we're also expanding the type of policies with WASM extensions. So WASM helps you to make Envoy proxies more powerful with custom business logic, and you can customize enforcement across the service mesh. We are building a catalog of such pre-built extensions, and one example we're proud to announce is a preview of a WAF web application firewall. It's based on the Corazza project, and it will provide application-level protection against potential threats within your network boundary. So to see how all that works, let's welcome Adam back with a demo.
Thanks, David. So let's introduce a new player into our demo. Imagine an organization is trying to harden their security posture. Maybe they're moving towards zero trust. So Elena, our security architect, steps into the picture and says, we need to segment our applications. Ultimately, regardless of where they're running, shared infrastructure or not, she wants to establish explicit relationships between applications that make calls to each other and have dependencies. So let's see how easy TSB makes this using some of the concepts that David just mentioned. So I'm going to log in once again, and I'm going to change hats. We're going to now assume the role of Elena, who's our security architect. That's part of the customer experience business unit. You'll notice once again, I now have a contextualized view. I can only see the customer experience tenant because that's the portion of the hierarchy, the business I'm part of. And I can see all the workspaces because I'm responsible for security across all the applications. You'll notice I only have the ability to add security groups, which is a construct that holds security configuration, but I'm not able to add configuration that would be related to ingress gateways, traffic management and how traffic flows, load balancing, and other. So to set a little context of what we're actually going to do, let's port forward. So we're going to connect into our customer 360 application that we just onboarded before with Amy. So this is our application. It's running in the customer 360 namespace. It's part of the mesh. We're going to test that it can actually connect to the ticketing application that we were just looking at. And so that ticketing application is in, or rather called, the backend service is what we're going to try and connect to, and the actual ticketing service of that. So we get a 200 response from that. Now that's taking place. We get a response simply because these are in the mesh. They're securing via MTLS, but after we establish that we're within the mesh, all services can communicate with each other. Additionally, we can look at our ticketing workspace and see the topology. And if we refresh this, probably within a few seconds, we'll see our customer portal application appear that is connecting to our backend service. Now, as we mentioned earlier in the setup, we want this to be explicit. We don't want this to simply work because they happen to be in the mesh together. And so to lock this down and express these explicit intents, we can use that capability David just mentioned of security domains. We can tag this workspace as being part of the logical notion of a CX secure domain. This now serves the underpinning of us starting to establish relationships between applications. So now that we've tagged this as CX secure, I can go up one level into my tenant, into the customer experience tenant, go to its settings, which then are inherited to every workspace. And in addition to requiring MTLS, I can say I'm going to set a custom rule that is explicitly going to say any application that is the target of a call that's tagged as CX secure, the caller or the source of the request must also be CX secure. Now, this is going to be translated into the proper configuration and applied to the actual Kubernetes services and applications that are running under the covers. As soon as this policy is applied out, you'll notice now I'm getting a 403 response from the backend service. That's expected because our customer 360 application doesn't have that tag we just talked about. So we want that though. We want to define this explicit relationship. So now all I need to do as a security architect is go into the workspace for the customer 360 application and tag that with the CX secure tag. As soon as we apply that, the configuration gets pushed out, and we should, if I talk long enough, it takes a few seconds for this to push out, our connection is reestablished. Now we've specifically have an explicit intent between our services. Now I could test that this had the correct effect because I can attach to another pod that's running within the mesh, a demo mesh namespace, but it's not part of these workspaces. And I can, test out the connection to see if I can also connect to the backend service. Now, if our security policy is working as expected, I would expect to get a 403 forbidden, access denied, because I don't have that explicit intent defined. I'm not part of the CX secure security domain with this application. And then lastly, as a security architect, I can go back to those metrics views, those topology views that we saw earlier, and identify who's calling who. And within a few seconds, we'll see metrics pulled in that shows we have the customer portal application calling our backend service, but we should also see an additional one that represents our connection test and demo mesh, which is what was rejected. It's highlighted in red because we have a 100% error rate. Everyone's getting 403 access denied because they're not part of that. So I can assure who's calling who and is the traffic flowing as I would expect. So what did we just accomplish there? Where Amy was able to create this logical construct of a security domain, tie that to objects within the TSP hierarchy, and use that as a baseline for explicit intent. In this case, saying the customer 360 application has a relationship with the ticketing services. They should be able to call each other. And then she was able to view these service dependencies across applications that are within her responsibility, identify who's calling who, and make sure the appropriate policy is in place. Now, Amy didn't actually take any action, but she sure accomplished a lot too, because her applications automatically inherited this authentication and authorization policy. And as you saw, we didn't have to redeploy the application. We didn't have to make any changes to application code. It applied to her applications seamlessly. And if we were to log in as Amy again, we could see those same dashboards that Elena looked at that show the relationships and the dependencies of who is calling who. So that wraps up our second use case. Let's go back to David to continue with our last one.